Hey everybody, thank you for joining me again. Alex here. We're going to teach you a little bit about inheritance today. Very fun topic, and that's going to segue a lot into object-oriented programming concepts, inheritance, overriding methods, superclasses, base classes, and all that good stuff. So let's get to it. All right, everybody. Thanks again for joining me. When we talk about inheritance, so let me write this here. Inheritance. Let's first talk about what every class in Java inherits from. Every class in Java is going to inherit from the object class. You may have seen the object class or some methods that are available to you from the object class, but this is your be all end all of classes. So every class is born from this object class on top. There is nothing above the object class. So the object class is like God. It says, "Let there be light," right? So think about that in terms of when we start thinking about inheritance. So something has to come from somewhere, right? In this case, in the Java world, God is object. So object is where it all began. Okay. Every class that you create is going to inherit from object. Okay, and then as you go down the chain, eventually you'll end up where if you're 3-4 levels down, so let's say we create a class here, and then we have another class here, right? If we're at this class level here, you know that everything is going to inherit not only from this class, so we'll call this class B, class A, and object class, right? So class B inherits, if it did inherit from class A, it would also inherit everything from object. Okay, so that's one concept that I do want you to be aware of. And it's one kind of sometimes popular question where they're asking interviews as to what is the one class that everything inherits from. So you can say, oh, object, right? So in this chain, you have class A inherits everything from, class B inherits everything from class A, and then class A would inherit from object, as we just said. The other thing we are going to learn is class A could have private methods and variables, as well as public, and class B may want to access things, but that's what the access modifiers are for, where if you have something that is encapsulated with inheritance, you're not able to access that encapsulated variables or methods. And I'm going to show you a couple of things. Now, let's look at some code real quick. All right, so what we're looking at here is an employee class. Suppose I'm building an application where I'm going to keep a database of employees and then do some type of payroll for employees. Now, in terms of design, that is something that is maybe a part 2 of object-oriented programming, and it's something that would be a course in itself. For now, I'm actually going to guide you on creating objects and showing you the object-oriented concepts. I think if I throw in how do we choose the objects and whatnot, right? It's just going to throw you in a loop. I'd like you to focus on one thing at a time, okay? So, and I will tell you why I'm doing certain things, but as far as yourself designing an application and just a data model, and also some action methods, that is something that is going to take time after you learn all the object-oriented concepts, okay? So I just want to throw that out there just in case you are trying to question yourself as to, okay, how do I apply this in the real world? So for now, the task at hand is we're creating an application. It has an employee database, and we want to create this application to store these employees, right? Now, in this class, which is called employee, I am going to declare a string name, then the hire date. And then I'm also going to have a simple constructor that will initialize my private methods. So no name, and then hire date would be new date, January 1, 2000. Okay, so basically we're just creating placeholders. So again, we're creating a simple constructor, no parameters, parameterless constructor. Okay, and then we're also going to create a second constructor here that is going to allow us to initialize the private variables when we Okay, so now that we have our class here, we have employee class, we have our two private members variables, instance variables, and then we created two constructors. The first constructor just will initialize the private members to some default value, and then this constructor we can pass in a name and a date, which will allow us to initialize it once we create an instance of the object. Then I also included some getter and setter methods so that we can get back the name. Remember, we want to encapsulate these instance variables, but we want to expose these methods so that we can access the values. Okay, and then we also want to be able to set the name of the employee and then set the hire date. So let's do that. Good. Now, so now we have this database, but what we want to do is we also want to create a class that represents a salaried employee and an hourly employee. Okay. Now, what I could do, and I can draw this out real quick. You know how much I love to draw, right? What I could do is, let me clear the canvas. I have an employee class, right? So we have employee here. We have our instance variables, which every employee usually will have, right? So the I have a little thing here. We have the name, and then we also have the hire date. Okay. So if I create a salary class, which has additional instance variables, right? So we'll call this salary employee. This salary employee class would also have, right, it would also have the name. It would also have a hire date, right? And then perhaps we also have other properties that belong to a salaried employee, such as maybe annual salary, right? So annual salary. And then we also think, well, my company, this company doesn't only have salaried employees, it also has hourly employees, right? So, okay, so let's design another class. We'll call this hourly employees. We'll have the same instance variables, right? Hire date, the name, right? Every employee is going to have a name. But in this case, we don't have a salary. We have actually an hourly rate, right? We can see that, right? Now, all these employees have a couple of things in common. Actually, two things in common. One is that every employee is going to have a name, right? So we know that. And the other thing is every employee is going to have a hire date. So if you look at in terms of a Venn diagram, let's use a Venn diagram, right? So a Venn diagram, right? We have employee over here. We also can have salary over here, and then we'll have something like here, and that's H, right? Salary employee is going to have some instance variables outside, right, that aren't shared in between here and here and here, right? So anything that's shaded would be anything that we share. Now, the way that I've built my classes right now, it's not very efficient because that means that I would have to create 3 classes. And every class that I have is going to have name and hire date as instance variables, and they're going to be repeated. And that's not a good system to design. Okay, we want to have reusability in your code, and you also don't want to write code that is going to duplicate certain things that should not be duplicated. In this case, name and hire date. So that's where inheritance comes in. That's where inheritance comes in. So let's take a look at a new picture. Okay. Okay, so here, what we have now is a better representation of what we should do. Okay, so at the top level, we're going to make use of inheritance. We're going to have an employee class, and then the employee class is going to have the name and then the hire date, right? Hire date. Now, in hourly employee, when we create that class, because we're going to inherit from employee, we do not want to redefine name and hire date. So that means that because hourly employee inherits from employee, we automatically get those properties accessible to us in our hourly employee class. Okay. Now, in my case, in this case, right, the hire date and the name as instance variables. Remember, so hire date and name, they are private, right? Which means that hourly employee, although it inherits from employee, I cannot access the instance variables. But what I could access are the setter and getter methods that I wrote in employee. Okay, so that's lesson maybe number 3 or number 1. I don't know what lesson we're at, but when you inherit from a base class, you are not allowed to access the private variables or methods. Those are inaccessible. Okay, at least in inheritance. Okay, so that's lesson kind of number 1. Let's call that lesson number 0. Okay, so now we're looking at access modifiers as well, right? In terms of terminology, employee is what we call the base class. Okay, so employee is the base class. Now, the inheritance can happen as a one-to-many, meaning that I can have one base class and my child class. I could have many children class. So as you see here, I have a salary employee and hourly employee, so many subclasses out of this parent class. So again, this is called, we can say it's a parent class, or we can also say that it is a base class. Okay? And the inheritance here goes up the line where employee now inherits from object, and we talked about object, right? That's the God object, the God class, right? So if hourly employee inherits from employee, that means that not only do I have access to employee methods that are public, right, but I also have access to the object methods that are also public. So the inheritance chains goes up, 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 up. So remember that if you have a couple of levels down in terms of inheritance. Okay, so it's pretty simple so far. All right, it can get really complex, but that's what I'm here for. That's why I'm breaking this down into like a couple of videos. Okay, so again, lesson number 1 is when you inherit from a base class, you are not allowed to access the base class's private members or methods. But you can access the public methods or public instance variables. Okay? You can only inherit from one class. So there's only one level of inheritance here. Which means that if I had let's say I had another class here, we'll call this, I don't know, bad employee. I don't know, I'm just making this up. This hourly employee cannot inherit from bad employee. Okay? Because we can only extend one class. We can only inherit from one class. So there must only be one base class. There can only be one. Okay? And now it's different I'm going to do a C++ reference. In C++, you can actually do multiple inheritance, but we won't get to that here. Okay? So again, only can inherit from one class. Okay? But you can implement multiple interfaces, but that's for future lectures. Okay, but for now, we know that we can inherit from one class. So now, if I write hourly employee, I don't longer have to write any methods or instance variables for name or hire date. Okay, so let me show you that in code, actually, how I would do that. Okay, so I want you to remember how employee looks, okay? Where we have a constructor, two constructors, one is without parameters and one is with two parameters, okay? And then we have a getter and setter methods for the hire date and name. Now, when we inherit from a specific class, we want to use the word extends and then the name of your class, and in this case it's employee. So I've defined a new class called salary employee, and that extends employee. Okay, and then my own salary employee class has something called annual salary, and then the same thing goes where the salary employee is going to be my constructor, and then this is another constructor, so I can have more than one constructor. Now you also notice something weird here. Okay, this word super. Okay, and then you also see it down here as super. So super is a way to tell Java to call the constructor of the base class. So remember what we talked about in terms of terminology. The base class here is employee, and by you doing super in this parameter-less constructor, you're actually telling Java, okay, I want you to call the parameter-less constructor of the base class by saying super. So if we go back to the base class, it's going to call this constructor here automatically, which will automatically assign the name and the hire date to default values, right? And then after that, it's going to come back inside here and then set my annual salary to 0. Good so far, I hope. Okay? So now if we omitted using super, Java will still invoke the base constructor. Okay, so it will still invoke the base constructor. Okay, so here's the second constructor that has 3 parameters, right? Where we're going to be able to instantiate an object of salary employee. So in here, when we instantiate salary employee, we're going to pass in a name, a date, and the salary. Now, you know the name and the date, we're not going to repeat the methods that we used in employee, right? So we actually would like to just call the base constructor and have it initialize it for us, which is exactly what we have the ability to do by using super again. So by me using super, I'm telling Java, hey, go up to the base class and pass in the variables that they passed in and initialize the private instance variables, right? Because remember, name and hire date also belong to salary employee. We're just inheriting them from employee, but they do belong to salary employee, except we can't access them directly. We can use the getter and setter methods from here, okay, from our salary employee. So by doing that now, we do have a name and a date, and then we're also taking the salary parameter and then initializing that to our annual salary instance variable, which is private. Okay, and then we also have a get and a set method for salary. And that's pretty much how things are shaping up in terms of inheritance, at least for the first part. Okay, so a couple of important concepts here. One, you learned about super. Super means we're going to make a call to the base class. If you leave out super, Java will still invoke it automatically, okay, at least for anything that's parameterless. Okay. The private variables that are on the base class are inaccessible to us in our child class, but anything that is public is accessible. Okay. And we still inherit the variables themselves, we just can't access them directly. Okay, so it is a big distinction. Okay, even though they are private and I can't touch them inside here, they still belong to the salary employee, except they're encapsulated inside employee. And the only way that I can access them is through the get and obviously the setter methods. Okay, so another important concept in terms of inheritance. Now we're looking at the access modifiers. Okay, and then if I create an instance of salary employee, that specific object can access all the public methods. So get name, get hire date, set name, set hire date. Okay, so that's allowed. Okay. Okay, on the next video, I'm going to go into this in more detail, and we're going to play with instantiation and see how all this kind of ties together. Look forward to seeing you in the next video.